Does the color of your cooler really matter? Lots of folks have said it does. In fact, if you look at some of the comments on other cooler test videos I've done, you're gonna see that all kinds of people say, oh, this wasn't fair, you didn't have the same color cooler. Of course the white ones are gonna do better than the dark ones. This cooler test isn't fair. To be clear, we're talking about ice retention and the impact that the color of your cooler has on how well it keeps things cold inside. I even took a poll on YouTube to ask you guys what you thought about this. Basically, half of people said yes, dark coolers are going to be worse at ice retention than lighter colored coolers. Though some of you thought that would only matter if it's in direct sunlight. 16% of you thought no, it's a myth, and the rest of folks weren't really sure. So let's test it.
Gear up and get outside.
Why are you so sweaty?
Because it is hot out here, which makes a great day for a cooler test. It is supposed to be in the mid 80s to upper 90s over the course of the next week, the duration of this test. So this hot weather gives us a chance to get a real solid cooler test. One other thing I have is a Bluetooth thermometer in each of these coolers. That will allow us to track the temperature variations over the entire test. We'll look at those graphs at the end, and I think that will give us an excellent indication as to the impact that the cooler color really has on the internal temperature, not just on the external temperature, which is where we expect the black one to be the hottest, right? We can also track the air temperature outside to see how that correlates with what's going on inside the coolers. What a great spot for a cooler test. This is south facing. It will be in the sun all the time. That's a wrap for today. Tomorrow I'll come back and do my first round of observations and explain the rest of this test. This video is sponsored by Blue Coolers. When I did my second Big Ice Challenge, the Blue was one of the top performers. I further confirmed how good Blue Coolers are at retaining ice when I did a test to see if any cheaper coolers could beat a Yeti. The Blue cooler I tested was $100 cheaper, and it handily beat the Yeti for ice retention. If you want to see that video and exactly what I'm talking about, go watch this. And I want to say that all those tests were done before Blue was a sponsor. I think the more square and deeper shape of a Blue cooler is part of the reason it holds ice better than a lot of the others. Plus it has all the other bells and whistles. And even this handy dandy pressure release valve, which if you unscrew that a tad after you've climbed or lowered an elevation, it'll be a whole lot easier to open that lid. The co-founder of Blue special ordered this black cooler specifically for this test. So right now this is a one-of-a-kind cooler, but depending on the results of this test, who knows? Maybe we'll see one of these roll out for sale soon. It's actually pretty cool looking. It has been 24 hours since I put ice in these coolers and left them here, so let's take a look inside and take our measurements. The first measurement I'm going to take is with this infrared thermometer, and I'm just going to shoot the top of that lid and take a reading on it. That says 154.9 degrees. Wow, I did not expect it to be that hot. And that says 134.1 degrees Fahrenheit. Finally, the white cooler, 94.1 degrees. That is a huge difference between the black and the white. That's what, a 60-degree Fahrenheit difference? Wow. Okay, if you guys are like me, some of your confirmation bias is already coming through. Here's the app on my phone that's connected to those Bluetooth thermometers. And as you can see, the number A there, that is the white one, and it's reading currently at 34.8. These are all bouncing around a little bit every couple of seconds it updates. B is the blue cooler at 35.7 degrees. C is the black one at 40.5 degrees. And then D is the outside temperature at 103 degrees. So that right there kind of gives you an indication of what's going on in the air inside the cooler. This is how it goes. When I open the cooler, there are 4 observations I'm going to make. Number 1, I shoot the top of the lid kind of in the middle, and I'm looking for a temperature of below 50 degrees. That's 43.2 degrees. It gets a 1 or a 0. 1 if it's 50 or below, 0 if it's over 50. The second observation is whether or not ice is present. The third potential point it can get is, can a can of soda sit on top of the ice? Something that kind of gives you an indication as to the surface tension of the ice and whether or not your cans are going to be on top or bobbing in the water. And that kind of also gives you an idea of how much ice there really is left. And the fourth possible point, I usually used a hot dog in the past, but now I'm using these bottles of water. I put this pin thermometer there, and I look at the temperature of that water inside. The sun's really bright, but that's reading out at just over 34 degrees, 33 degrees. When I'm checking the water temperature, I'm looking for a temperature of 40 degrees or below because that is what the FDA says is a food safe temperature. There is a total of 4 points possible per day per cooler, and the cooler with the maximum number of chill points wins. But because we're testing color specifically on this test, I wanted a little more insight. That's why we're gonna track the internal air temperature with the Bluetooth thermometers inside, and we're also taking the temperature of the lid on top, because in the end, we really just wanna know the difference in performance you can expect from different colors of coolers. Now I'll go ahead and take the observations on the blue one. 41 degrees, not bad at all. There is ice. The cans of soda are obviously on the ice as well. And the temperature of that water is a cold 33 degrees. 4 points on white, 4 points on blue. But it's this black one that has me really curious. That is below 50 degrees, 43. That's not too bad. There's plenty of ice and there's cans on top of the ice, so that counts. And that water too is at 33 degrees. But one thing I can already visually observe a little bit, it looks like the ice levels might be a little bit lower, and there's a little bit more separation on the sides here in the black one, which, by the way, that's normal. Every time I do these tests, I notice that on day one, because the coolers are generally a bit warmer when you start, and it takes them a little while to cool down. Just for comparisons, let's take another look at the blue one. You know, actually that doesn't look too different. Yeah, and I'd probably say that gap is a little smaller on this white one. See if you can get good light there. So that's it. That's how this test is gonna work. I'll come back every day and do the same thing until the test is over. I'll bring you along to see some of it, but I'll try not to bore you, and we'll look at all the data at the end. All right, it has been about 2 full days since this began. It is 5 p.m. and I just took my measurements. The lid temperatures on the coolers were as follows. The white one was 97 degrees, the blue one was 132 degrees, and the black 144 degrees. So far what's surprising me is how close the blue and the black are. There's also a significant difference among the air temperatures inside the coolers, 35 on the white, 39 degrees on the blue, and 41 on the black. Not too different from yesterday though. The water temperatures were all the same at 33 degrees. Now both the white and the blue got all 4 chill points today, but the black one got a 0 on the lid temperature. It was 55 degrees, so it is clearly getting a lot more heat through there despite the same amount of insulation. While we're waiting for ice to melt, I figured I would reach out to some experts. I thought if cooler companies are the ones making these coolers and selling them in all kinds of different colors, they ought to know which colors perform better than others, right? So I sent the same email to about 9 different cooler companies. This is what I asked. How much of an impact does the color, dark versus white, of a cooler have on its ability to retain ice and keep things cold inside? Let's take a quick look at some of the responses I got. Arctic was the first company to respond, and they said that colors won't change the cooling performance. I was glad to see Blue Coolers had such a quick response in only 30 minutes, and they said dark color coolers will attract heat more easily compared to white coolers, but both should still have good ice retention, and that ultimately temperature would be a factor. Yeti responded pretty quickly, and they said it doesn't depend on color, and also that color can impact ice retention. That was confusing. They gave both answers. I think it was just a mix-up. Cordova also said color has no impact. Orion says they've done some tests and they've had the same results for both light and dark coolers. But that the external temperatures on the dark coolers are going to be higher, so they recommend a lighter color if you want to sit on it. Good idea. Igloo offered the most precise answer. They said if it's going to be exposed to the sun, then yes. But if it's in the shade, the differences are going to be negligible. They also said they have no real data about it. Orca said that their tests show no difference based on colors. Coleman also responded saying the color of the cooler does not impact its ability to retain ice. So by my count, that's 5 companies that said it definitely does not matter what color your cooler is. Yeti gave both answers to cover all the bases. Igloo was very clear in their response, and Blue also said that color can affect the temperature. But that is probably not a big deal. Let's get back to the test and find out for ourselves who was right. It has been 4 days, count them 4. Sodas are now bobbing, so this got 0 on one of the 4 points, so a total of 3 out of 4. Here is the blue cooler. Actually, that ice looks pretty close, but it definitely is in the middle of the white and the black, as you'll see. This one got 3 out of 4 points. On our black cooler, also soda's bobbing. That lid was well above 50, I think 55, 56, something like that. But there appears to be quite a bit more water in this one than the others. Also of note, this is super hot. I mean, look at that, now it's reading at 174. Earlier when I shot it, it was 170. But 174 degrees on that lid. That is hot. Compare that to the white one here, where we're getting 108 now, 108. And the blue one, 150 right there. I am pretty surprised by how hot the blue one is. It has been 6 full days, and folks, we have something to report. The black cooler is out of ice. Look at that, all water, no ice. Looking at that water temperature, you know, 51, 52 degrees. The internal air temperature in this cooler before I opened it was also pretty high. I think it was 67 or 68 degrees. By comparison here, if we look in reverse order, here is the blue cooler. There is still ice. It got 2 out of 4 points today. And here's the white one after 6 days. Definitely still some ice left. More than the blue cooler, it looks like. I mean, I guess we could even just end the video here and just say, yep, the black one's gonna run out of ice before everybody else does. But I'm really curious to measure the exact differences and see what else we can learn from this and how big of a difference it really makes. I'm also curious if it makes any difference if these were left in the shade. Today marks 1 full week since these coolers have been out here, and it also marks a huge change in the weather. I mean, it dropped 25 degrees from yesterday to today. We had this big thunderstorm, rain, the whole bit. As you can see around me, it is overcast. It has cooled way down, so that has sort of thrown a curveball into our little experiment here because it threw off the final results. If it were another 90+ degree day, I think all of these coolers would be out, but our white one is still in the race. Check it out. There is the white cooler with ice still remaining after a full week. Today we can see in the blue cooler, it is indeed out of ice and out of the running. If it were hot, I suspect the white one, maybe it would still have a little bit of ice yet left. But at the end of the day, none of that matters because what we did learn is that the black one is definitely gonna run out of ice before a white one, and then a cooler color in the middle is probably gonna land somewhere in the middle. But I can't help but wonder if it's more nuanced than that. The game is over, let us observe. Today, the white one is plumb out of ice. Despite the advantage of having those really low temperatures, it still ran out of ice. And truth be told, I actually checked this cooler this morning and it was out of ice already. Let's take a look at the results. What surprised me the most was the exterior surface temperature of the lids. As you can see in this chart, the black cooler was way hotter, as hot as 170 degrees Fahrenheit. That's 77 degrees Celsius. The white only maxed out at about 109 degrees Fahrenheit or 43 degrees Celsius. The blue cooler was also hotter than I expected. While it did fall in the middle of the white and the black, it was closer to the temperature of the black cooler than it was of the white. Note also on this chart in gray, the outside temperature in the sun as measured by the same type of thermometer we had inside the coolers. One thing we learned from this is that if you want to sit on your cooler as a seat, either in a boat or anywhere else, get a white one or at least a light colored one, because a dark one, especially a black one, is really going to burn your britches. This chart shows the internal air temperatures of the coolers. The vertical lines represent midnight each day. The peaks are the hottest part of each day, and the little spikes you see in there at the top of the peaks are when I open the coolers. The low point of the troughs are the coldest part of the early morning. There was definitely a wide spread in the internal temperature between the white and black coolers, and with the blue one falling again in the middle, but still closer to the black than the white. The black cooler was as much as 10 degrees warmer inside than the white cooler, but even the blue cooler was about 8 degrees warmer inside than the white one at its warmest. Keep that in mind if you're going to use baskets or trays for veggies and things like that aren't going to be sitting down in the ice, but rather above it. It looks to me on this graph that the black cooler ran totally out of ice after midnight on day 6, so it made it a total of 5 days and then some with ice. The blue cooler made it 6 full days, but not quite 24 hours longer than the black one, despite the much cooler outdoor temperatures on that last day. The internal drink temperatures remain virtually the same, and judging by this chart and this test, the color of your cooler doesn't really matter as long as the contents of your cooler are submerged in the ice. When it comes to the chill points, you know those 4 observations I was taking every day, the white cooler got 24, the blue one got 19, and the black one got 15. Now I was a bit suspicious that this full sun test didn't tell the whole story about the differences in performance among different cooler colors. So I wanted to also test this in the shade where sun wouldn't be a factor. I made this test simpler because I didn't want it to last forever. So what I did is I got 3 10-pound bags of ice. I put 1 bag of ice in each cooler. The coolers were put up against a north-facing fence in my backyard where they got absolutely 0 sun for the whole test. This way it would be a much quicker experiment. I still put that water bottle in there because I wanted to be able to take the lid surface temperature and also the drink temperature inside the cooler. And then of course I had the thermometers inside there. I opened the coolers daily and I made those observations. I recorded the temperature and whether or not ice was present. I didn't do the full chill points thing. And I should also note that the weather had cooled off dramatically since the first sun test. So it was only in the low 70s during the day when I did this test. Here are the results of the shade test. In this chart, you can see the external surface temperature of the lids of the coolers. And as you can see, they were nearly identical to the ambient air temperature outside. and the difference between the white and the black and the blue was negligible. When we look at the internal temperatures of the coolers, they tracked almost identically as well. There was never more than 1 degree Fahrenheit difference, that's only about half a degree Celsius, between the black and the white coolers, with the blue lying in the middle. That little difference could possibly even be explained by instrument error. Regardless, all 3 coolers had ice for 3 full days and then it melted at the same time. The drink temperatures of the water bottles inside the cooler were also identical every single time I took an observation. Here's a summary table of the results. In our sun test, the white cooler went 7 days, the blue cooler went 6, and the black went 5 full days before they ran out of ice. But I'm pretty sure if those 100-degree temps had held, that white cooler would have gone out of ice a day earlier. You can also see in here the average temperatures for the lid, the inside air, and even the drinks inside. But in this table, I just highlight the actual differences. And you can see that in full sun, there may be quite a big difference in the external surface temperature and the internal air temperature, but not really any difference in the temperature of the contents. And then in the shade, there's pretty much no difference at all that's significant. In the end, it looks like Igloo and Blue coolers and the 26% of the people who responded to our poll on YouTube were correct. The color of your cooler does make a difference in how cold it remains inside, but only in direct sunlight. There is virtually no difference when kept in the shade. And even in the sun, the contents of your cooler should remain just as cold when kept in ice or ice water. Really, the sun doesn't make a huge difference in the grand scheme of things. If it would have stayed hot during my experiment, I'm pretty sure the blue and the white coolers would have ran out of ice at about the same time, meaning they only would have outlasted the black cooler by about 1 day, over the course of nearly a week. In real-world conditions and for most people, it may only make a difference of a half a day or a few hours. And that's over the course of a multi-day trip, meaning you probably won't even notice it on a weekend campout, even when in full sun. So does cooler color really matter to you? I suggest that depends on how you're going to use it. If you're going to use your cooler on a boat, keep it in the back of your truck, strap it to the top or the back of a van, or you're simply going to be using it in places like the desert or other places where you have no shade. That's when you really might want to pay attention to the color of cooler you purchase and err on the side of white. Now go watch this video where I test 38 different coolers in an ice challenge head to head, pretty much all shade, all different colors, all different sizes. It's epic. Check it out. Thanks for watching.